So the NGSS standards that we use are MS ETS 1-1, and it is define the criteria and constraints of a design problem with sufficient precision to ensure a successful solution, taking into account relevant scientific principles and potential impacts on people and a natural environment that may limit possible solutions. MSETS 1-2, evaluate competing design solutions using a systematic process to determine how well they meet the criteria and constraints of the problem. And MSETS 1-3, analyze data from tests to determine similarities and differences among several design solutions to identify the best characteristics of each that can be combined into a new solution to better meet the criteria for success. So we decided to do the Pringles Ring STEM Challenge. So for this, we are asking students if they can build a ring using only Pringles. So there's no tape, no glue allowed, and they are only limited to using one single Pringles box. And before they start, we want to give them a set of questions, and it's kind of like a template where they can fill out their answers. And we can ask them how many chips are in a container, about how many chips do you think that you will need to build the ring. So before they start this challenge, they're going to fill out this sheet and they're going to fill in their answers. And then we're going to also have them sketch out their plan and see how they want their ring to look and what their base might look like. And then after they complete the ring, we will have them answer the questions of how many chips did it actually take to build the ring, and if you were to do this challenge again, what would you do differently? So we believe that asking these questions throughout the STEM challenge, it's going to help the students really think through their challenge, and it's going to help them kind of visualize and try to think about the process in order for them to be able to come up with solutions on their own. And we're also going to have them kind of think about the physics behind the challenge. So how does the Pringles ring work? And then we're going to have them think about gravity and how gravity affects how they build their Pringles ring. Because as the sides of the ring get taller, gravity starts pushing them down. And it causes the chips to start sliding down, and in order for the chips to not slide down, there must be enough frictional force on the sides of the chips so that gravity can't push it down and so that their ring won't break apart. So we decided that for this type of STEM challenge, we could possibly do it and pair students in groups of 2 to 3 people. One of them could be recording on their recording sheet while the other 2 could be trying to figure out how many chips they need to layer at the bottom of their base in order to keep their ring sturdy and in order to complete a full ring. And we want to give them a time frame between 35 to 40 minutes to build their Pringles ring and see who can build it within that time frame. So as we can see here, this whole video is just a time lapse of us trying to make our own Pringles ring. And at the end, we are able to succeed. And then what we would have students do after, our timer is up, we would put a timer between 35 to 40 minutes. Not everybody might finish building the ring. It just depends on how well they are able to construct their base. But then that's why they would go around and try to figure out and analyze their design and try to guess what they could do differently next time around, or what design solutions they can do in order to create a ring next time around. But at the end of this video, we have an example of what the ring should look like.